All right, this is the video for 7.1 and a lot of the vocabulary that you're going to need for this chapter. I think the best way to do this is with a video, just because you can rewind it and look back if you miss something. So yeah, I think this is the best way to do it. We're going to start out talking about polynomials and what they are. And really, I think the best way to think about a polynomial is just a group of powers. So if you remember what a power is something that has an exponent. So if we just take a group of powers and connect them together, so for example, like 5x to the third would be a power, and we'll connect it to another one. I'm making up numbers, by the way, plus 2x squared minus 4x plus 8. For example, so each one of these has a power. So this one has power 3, power 2, power 1, and then power 0 would have no variable whatsoever. Anytime you have a graph of a polynomial, you'll know that these will be continuous graphs. Continuous graphs. So in other words, there'll be no holes. There'll be nothing missing, or no asymptotes. So anytime you have a variable in the denominator where there's some numbers that if you plug them in, you'll get an error, these will not be graphs of polynomials. The other thing will be graphs with no corners. So think of graphs like absolute value, things like that have a corner in it. Those will not be graphs of polynomials. As we go through this vocab, the first thing we'll talk about is standard form. You'll know that you're in standard form if your exponents are in order from biggest to smallest. From biggest to smallest. So let's take a look at the polynomial that I already wrote down, and let's check to see if it's in standard form or not. If I look at it, the biggest exponent is a 3 and it's first. The next is a 2 and it's second, and then a 1 and then a 0. Yep, that one's already in standard form because we have the biggest exponents first. The coefficients, these are numbers in front of variables. Numbers in front of variables. So for example, if I have 3x squared, the 3 is the coefficient because that's the number that comes in front of the variable. The lead coefficient is the coefficient in front. I'm going to spell this wrong, 2 F's. The coefficient in front. So basically, if you put it in standard form, then you'll have your biggest exponent out front, and then the coefficient that comes in front of the variable with the biggest exponent is going to be the lead one. So the key here is that first you need to put it in standard form. A constant is a number with no variable. So think about the example we wrote down about what number would be the constant. If we look up here, this number 8 has no variable attached to it, so we're going to call that a constant. The degree of a term is going to be the addition of exponents. Most of the polynomials we look at are only going to use one variable, but sometimes they use multiple. So for example, if I have a term that says, x squared y to the third, like that, if that's my term, the degree of this term would be a 5 because we're going to add those variables together, or those exponents together. Okay, we're going to look at a polynomial. I'm going to tell you the name of it and then give you an example for each one. So if the degree is 0, first of all, the degree is the biggest exponent. is the biggest exponent. So if the degree is 0, we're going to call that a constant. So for example, we already talked about one. A constant would just be the number 8. It's got an x to the power of 0 hooked up to it. X to the power of 0 is 1. So yeah, so it's just a number all by itself. If the degree is 1, that means the biggest exponent is a 1. We're going to call those things linear. So an example would be 3x plus 2, for example. We know that if we graph 3x plus 2, that would be linear. And if you look, the biggest exponent is a 1. Or maybe just, how about x minus 5 would be another example. Anything where the biggest exponent is a 1. If the degree is a 2, we're going to call that quadratic. Think about the things that you plug into the quadratic formula. So for example, 2x squared might be quadratic, or x squared minus 4x plus 7. It's okay if it has an x in it, it just has to have the biggest exponent be a 2. Power 3, we're going to call this a cubic. So for example, 2x cubed, like so. If the degree is 4, we're going to call this a quartic. So an example would be 7x to the 4th plus 2x to the 3rd plus x cubed minus 8. Once again, it doesn't matter that we have these other powers in here. What matters is that the biggest one is power 4. Last one is a quintic, power 5. So 3x to the 5th, for example, and you get the idea, as long as the biggest exponent is a 5. All right, the next thing that we're going to talk about is how many terms are in each polynomial. If we're looking at a monomial, you guys probably see the word mono in there. That just means one term. It doesn't say anything about what the exponent is on that one term. It just says there's one. So for example, 5 would be a monomial. There's one piece. Or maybe 3x. Because these are multiplied, those are going to be considered one term. Or maybe 7x to the 5th power. That's a monomial. All these are multiplied. Binomial would be 2 terms. Like that. So maybe x plus 7. As soon as you add addition and subtraction in there, it creates another term. So those are 2 separate terms. Last one, trinomial, then 3 terms. So if I have this one right here, maybe 2x squared plus 7x minus 8, for example. If I look at that, here's term 1, here's term 2, here's term 3. So I'm going to call this a quadratic trinomial. Quadratic means power 2. Trinomial means 3 pieces, so we have that name for it. All right, you guys can stop right there. These examples that we look at right below, we'll talk about in class. Hopefully you're still awake.